Okay. Hydrolysis. So the problem we sort of talked about this earlier. Up until this level, we called everything that started with an H an acid, and everything that ended in an OH a base. Clearly, that is a very limited definition because when you put sodium phosphate, this, or iron chloride, iron 3 chloride, into solution, you get an acid and a base happening. Okay? There are no hydrogens in either one of those molecules or hydroxyl groups. So what is happening? This is hydrolysis. All right. When you dump salts into water, you can have an acid formed, you can have a base formed, or you can have no reaction. No acids or bases. Okay. So it's always a salt. When we talk about salts, we're talking about ionic compounds. If you remember from grade 9, 10, 11, I guess. So there's the classic actual salt, NaCl, but it could be anything. It could be potassium. Well, potassium phosphate's a salt, right? It's a metal and a nonmetal, or a metal and a polyatomic, like this. All right. When you put them into water, you can get, they can form acidic or basic solutions. Not all will do it, and we'll see why. Some will and some won't. Okay. So if we take sodium phosphate, Na3PO4, put it into water, what happens to the salt? It dissociates, right? And we get sodium, 3 sodiums, I guess we'll balance it. And we get a phosphate group forming. So now we look at each one of these. Does sodium ever do anything? No, it's a spectator, okay? So sodium does nothing. We don't care about it. It's a spectator. But the phosphate does something. PO4 3 minus, that has a charge of -3. We know that water is polar, right? It's got some charge separation. So you, come on. Oh my gosh. It's a sign. Okay. There we go. I know, you're all disappointed. So we know that water has this charge separation. The hydrogens have positive charges, slight positive charges. The oxygen has a slight negative charge. Anyway, this phosphate is a 3 negative. It's going to see this partially positively charged proton, and it's going to rip the proton off of it, okay, in an acid-base-like reaction. And you're going to get HPO4 2 minus now, because you dumped a proton onto it, and OH minus, which means this solution should be what? Acidic or basic? Sorry? Basic, right? We formed an hydroxyl group, okay, which is the classic base. All right. So we call, and which ion reacted? It was the negative ion. What do you call negative ions? Anions. So this is called this is called anionic hydrolysis. And then we can say that sodium phosphate is a basic salt. Because when you throw it in water, it forms a base, a basic solution. Okay, does that make sense? All right. Ammonium chloride. Put it into water, what happens? It dissociates. So we get this. Okay. Which one of these is going to react? You have two choices. You got the ammonium and you got the chlorine. Which one's going to react? Cl? Okay, so let's do Cl. Off to the side. Way over here. So Cl minus, if we think of it, with water, what's it going to do? What? It's going to accept the proton? Okay, so what do I get? What's wrong with what I wrote? Why is it there's no way this would happen? Who said that? Because HCl is a strong acid. Do strong acids form? What do? They dissociate 100%. So there's no way this happens because as soon as this forms, it goes, no. And it goes that way. So nothing happens with the chlorine. All right. If when you pick up a hydrogen and you form a strong acid, which remember at the top of your table are those, the ones that don't have a Ka, they will not form. It's just going to be like, no, not happening. And it pushes back the other way. So the chlorine doesn't do anything. Okay. So this is a strong acid, therefore won't form. Okay, so really all we have to worry about is the ammonium. So we take our NH4. We have water. The only thing that can happen is what? Will the ammonium accept a proton? Highly unlikely, because it's already charged, but it's going to dump one, right? So we'll get ammonia plus H3O plus. So is this acidic or basic? It's acidic. So we would say that ammonium chloride is an acidic salt. What type of hydrolysis is this? If the last one was anionic, this is cationic. Okay, so you can always check both ions, but if it forms a strong acid, it's not going to do anything. It'll push back, so that won't even happen. All right, are we okay? Boom. KBr, potassium bromide. So the cation is potassium. Do alkali metals do anything ever? And that's a baby, not a happy baby. Ooh. That's Miss Pushka's. Oh, no. Okay, so the alkali metals, nothing happens. What about the bromine? Br minus 1. Sitting there. We react it with water. What does it form? Forms HBr, but what do you have to look at on your table? It's a strong acid, so does it form? Nope. So it actually goes that way. So what do we say? The last one was acidic salt. There was a basic salt, so this one will be a neutral salt. You tell me.
Yeah.
Why?
Because the Na doesn't do anything, the Cl can't do anything.
There you go. And if it wasn't, when you put salt into your food, you'd form acid on your food. Which would not be a good thing, right? I mean, maybe it is. I don't know. It tastes sour. No, what do acids taste? Sour? Sour. So I don't, because I don't taste it. All right. So that's probably a good thing that it is a neutral salt. All right. Ammonium sulfates. What do we have to check? What ions? There's only 2 ions there. And there you go. So we just checked the ammonium. And we have to check the sulfate. All right, what's the ammonium going to do? It's going to give. So we get ammonia and HCO plus. So we know that can happen. That's cationic. What about the SO3 2 minus? What's it going to do? It's going to accept. Will that form? Is HSO3 minus, all you have to ask yourself is HSO3 minus a strong acid? It is not. Therefore, they both happen. All right, because this is a weak acid. You can check your table if you don't believe me. So we get both anionic and cationic hydrolysis happening. So we're not going to do it today. Tomorrow, we'll learn how to determine who wins. Okay, because there's a battle going on, right? So is this solution going to be acidic or is it going to be basic? We'll figure that out tomorrow. That's tomorrow's lesson. Okay, so we call this double hydrolysis. Okay, so we'll determine the acidity later on. All right, last question. CrH2 6NO3 3. What are the 2 ions? Chromium. And sorry, what? NO3? Yeah. So we're checking these. 3 plus water. What is that thing going to do? Is it going to donate or accept? It's going to accept.
There's really 2 answers here.
Does it want to pick up a proton?
Not really.
It's got a +3 charge on it. Do we want to add another positive charge? Probably not, right? It's probably want to go back to neutral. So it's going to dump a proton. So what happens is one of the waters gives up a proton. So the waters go to 5, and you have a OH minus attached as well. And you get that. Will that happen? So go to your data table, data booklet. Where's the chromium thing? Hexa, there it is right there. Boom. Okay, so that is a legit acid. Okay. So that will happen. So we will get cationic. Whoop. But we have to check the anion, which is NO3 minus. If we react that with water, this goes to the question that you had on your test, the quiz. We get that. What's the problem with that? Yeah, nitric. It's right there. It's a strong acid. So it doesn't form. That's why we didn't need to worry about the nitric. So this is a no because strong acid. Therefore, this is an acidic salt. All right. So basically, you're just looking at the 2 ions that are in the salt. When they break apart and they hydrolyze, just check to see if they form a strong acid or a strong base, in which case those things will never form and will push back. Okay. Just we can fill in this summary quickly and then we're done. Alkali metals, do they ever do anything? No, they don't hydrolyze. anions of very strong acids. So this is the Cl minus, the NO3 minus, are also spectator ions because if you hydrolyze those, you form a strong acid which never sits there. It always dissociates 100%. All right? Is it Z or S? Hydrolyze.
Language.
Is it can be either.
Yes.
And then American would be Z. Let's go with Z. Cationic hydrolysis, always. Cations always produce what type of solution? It's going to be a yes. Because it's a positively charged something. So say, I can't think of one right now. She's the one we used. Ammonium. It's going to want to donate a proton. So it'll be an acidic solution. Anions, well, because they're negatively charged, will accept a proton. So that'll be a basic solution. If only the cation hydrolyzes, it's acidic salt. If the anion hydrolyzes, we call it a basic. If both I can't even see the word. If both things happen, we will call it a double hydrolysis. Where nothing happens, they are neutral salts. And highly charged hydrated metal cations. So that is this thing. That's a metal cation that is hydrated, highly charged, +3 would be considered high charge. Act as acids or bases. Acids. They are also known as Lewis acids, another type of acid. So we went from just calling things H's, start with an H as an acid, to we had the Arrhenius, then we got the Bronsted-Lowry, and now there's also Lewis acids. Okay, that is the lesson. You can fill out the rest of it. I am done for today. We have a short lesson tomorrow, and then it's review test on Thursday.
That's on Thursday.
That's on Thursday.
Okay, so why does this not happen?
Hang on.